So you're not audible.
8, 9, 10, 11, 12, 13, 14. The IC 14 pins IC. It includes 6 not pins. Okay. Hello, you are not audible? Hello?
So it was not audible, sir.
Okay. So what we are understanding here is for each logic we have this dedicated ICs. Our standard ICs are available for implementing each logic. Like for NOT gate, there is a IC called 7404. And similarly for different IC number for AND gate, NAND gate, NOT gate, and XOR gate, like that. So the various 74. This is the IC. The black what we are seeing is ceramic coated. Within that there is a semiconducting material, semiconducting chip that we are calling it as a chip. This 7404 is integrated 6 NOT gates. 6 NOT gates are integrated in one IC called 7404. You can use any number from 1 to 6 NOT gates you can use if you require, like that. So how you can access these gates? These gates are accessed through the IC pins. Say these are the pins, and so the actual IC looks like this. We will see while doing the demonstration. And how you can recognize the pin? There will be a sheet you will given, like a data sheet will be there for each IC, and in the data sheet you will have the description like this. And this is a curve. You specify that from below. This will be the pin number 1, and this 7404 is a 14 pin IC. The 7404 IC is a 14 pin NOT gate IC, right? And how you can identify the first pin? Just by this curve, right? And respect to that curve down, you have to start. This is a pin number 1. Now you are seeing the screen and listening, right? Hearing properly.
Yes, sir. Yes, sir.
So this is the pin number 1, 2, 3, 4, 5, 6, 7, and then again like a clockwise. This is 8, 9, 10, 11, 12, 13, 14. This is like the ICs are there. We'll see the physical actual IC. We'll see in the demo part. Okay. So each IC like this. See, if you want to use one NOT gate, you can use this as, you can consider this as a input, and this you can consider this as an output. So if you want to realize this gate, what you have to do is, usually for input, where you are connecting, for input, how to connect for input, what to connect to input, and what output should be. Usually inputs are switches, right? For realizing the logic gates or experiments, usually you should remember that the inputs are switches for doing the experiment, and outputs are usually indicators like a LED, right? So to realize the NOT gate, you have to connect a switch to this gate, and you have to connect the LED to another gate. See, if you make a switch on, then LED will be off. If you switch off, LED will be on. Like that, invert operation. That is how you can do the experiment. Okay. Then similarly, the IC for OR gate is 7432. Even while doing in actual lab exam, or you will get the data sheet for the each IC. You can refer. Okay. So if you want this 7432 is a OR gate IC. It includes 4 2-input OR gates are there. Okay. And pin description are given here. The pin number 1, 2, 3. Pin number 1, 2 is input of first gate, and 3 is output of the first gate, and 4, 5 is input of second gate, and 6 is the output. And the pin number 7 is used as a ground. Each IC, the important point we should remember is, each IC should be connected with a ground and VCC. The ground means 0 voltage, and VCC is the plus or high voltage, like in terms of maybe if you consider as a 5 volt, right? Usually 3 to 5 volt will be there for high logic. So VCC is a high logic, like positive level of the voltage which is required to drive the entire circuit. Okay. So this is the ground. Pin number 7 should be connected to the ground, and pin number 14 should be connected to VCC. And then pin number 8 is the output of third OR gate, and 9 and 10 is the input of third OR gate. Like that, this is the pins of fourth gate, like this. And already we know the logic truth table for OR gate. What is the IC for AND gate? IC for AND gate is 7408. So same way, you may ask the question, why these pin numbers 1, 2 like this? The vendors or who is manufactured, they develop like that, and we have to follow the pin configuration as it is, right, to access the logics from the standard ICs. Okay. This is a 7486 is a gate for IC XOR IC. 7486 is IC for XOR logic, and XNOR is 74266, and for NAND gate 7400. And this is the 7400 is a 2-input NAND gate IC. And if you want to use a 3-input NAND gate IC, there is a IC number 7410. See here, 3 inputs are there, and the total number of gates integrated into this standard 7410 IC is 3 NAND gates. Okay. Then 7420 is a 2 NAND gates are integrated into this IC. These are the different ICs. If you want to use a 3-input NAND gate, there is a different IC. 3-input NAND gate is different. 4-input AND gate IC is different. Okay. Then this is the IC for NOR gate 7402. Okay. So this is how the logic gates. Okay. Now